Hello, this video is all about BBots and how they can be used in a Year 2 classroom to develop computational thinking. I'm Emily.
And I'm Helen.
And we'll be taking you through the content in this video. Throughout this video, we will discuss how the 3 activities created will enhance students' knowledge of coding and facilitate computational thinking.
During Activity 1, students create flowcharts and complete simple sequences based around what transportation do we take to school. From this data, students create a simple flowchart like the one pictured describing this process.
Activity 2 is split across 3 phases. In Phase 1, students direct the teacher around a floor grid map, like the one shown here. Directional language is introduced in this phase, and flowcharts are created to represent the path. In Phase 2, students practice by programming the BBot to move 6 to 12 steps and translate this path into a flowchart. In Phase 3, as a class, students are given a flowchart and are required to predict and draw what the path will look like.
In Activity 3, students read a text about Barry the BBot farmer, and from this make a sequential list of his chores. From these chores, students create a simple flowchart including directional symbols. When they have completed the algorithms, they are encouraged to test and debug.
We will now highlight the links to curriculum areas other than the digital technologies curriculum.
The digital technologies lessons can connect with the key curriculum area of mathematics. Students look at providing a list of directions to their peers and also creating their own flowchart of directions.
Due to the inclusion of a written text, students will also connect with the English curriculum. They will identify information and detailed instructions from the recount in order to create a sequence of steps. Now let's discuss what computational thinking is and how it developed in the activities.
So what is it? Computational thinking describes the processes and approaches we draw on when thinking about how digital technologies can help us to solve complex problems. So we draw on logical reasoning, algorithms, decomposition, abstraction, and patterns and generalization when thinking computationally.
The 4 computational thinking strategies developed in the lessons are listed here. Decomposition is the process of breaking down data, processes, or problems in your mind into smaller, more manageable parts or problems. Then, the smaller parts can be examined, solved, and designed individually because they are smaller to work with. Students develop and use decomposition strategies in lessons 1, 2, and 3. These are explained on the screen. The process of decomposition takes away the sometimes overwhelming and daunting challenge of completing a big or challenging task. We sometimes have to decompose a problem in more than one way to fully understand it.
Abstraction is defined as identifying the crucial elements of the problem. Abstraction is found in Activity 3 where students simplify the text and pick out Barry's chores. The importance of abstraction is that it allows us to view things at different degrees of detail. For example, when students read the text, they can remove the waffly bits and highlight the locational language.
The process of developing algorithms involves creating step-by-step instructions to solve problems. In the activities created, students develop algorithms through flowcharts. The flowchart algorithms created by the students are directionally focused to be able to complete the tasks. Algorithms are a critical foundation for learning to program. Without them, no program would run. They are instructions or rules that, if followed precisely, whether by a person or computer, lead to a similar or identical result.
Debugging is the process of locating and removing bugs and errors. This process allows for checks, detections, and corrections of errors. Debugging is found in all lessons where flowcharts are used as students can experiment and make changes whenever errors occur. It allows a user to simply correct these errors and make adjustments.
We have learned that technologies can be integrated with other curriculum. Decomposition is breaking a big problem down. Abstraction is picking out important information. Algorithm is creating simple tasks. And debugging is correcting mistakes and errors.